Come in. You are welcome here, just as you are. If you are still settling into bed, take your time. There is no hurry. The pillow can wait a moment longer while you find the shape of your rest. Let your shoulders drop away from your ears. Let your hands fall open, if that feels right. The day is already behind you, and everything that needed to be done has been done enough. Right now, there is nothing you need to solve, nothing you need to hold on to, just this voice, moving slowly through the dark, keeping you company for a little while before sleep comes. You do not need to follow every word. That is important, so I want to say it plainly at the start. This is not a lesson you must remember, not a story with a test at the end. Think of it more like music heard from another room, or the sound of rain on a window. If your attention drifts, let it drift. If you miss a sentence, let it go. The words will keep coming, steady and soft, and you can pick up wherever you find yourself. Nothing will be lost. This whole hour, if you stay awake through it, or if you are gone after 10 minutes, is meant to be a gentle space to rest inside. That is its only real job. Tonight, we are going to sit with a question. It is one of the oldest questions people have ever asked, and also one of the strangest. It is the kind of question a child might ask while looking up at the night sky, and it is the kind of question that a physicist, after a lifetime of study, will still admit they cannot fully answer. The question is this: what is outside the universe? If the universe is everything, if it holds all the stars and all the galaxies and all the space and all the time we know, then what could possibly be outside it? Is there an outside at all? And if there is, what would it be like? I want you to know, right here at the beginning, that this question does not come with a neat answer. That is not a failing of the question, and it is not a failing of science. It is simply where we are, honestly, in the long, slow work of trying to understand the whole of things. Some questions, the very biggest ones, stay open for a very long time. They stay open across generations, and that is not a source of frustration, not really. It is more like a companion, a quiet presence that walks beside us as we keep looking, keep measuring, keep wondering. The not knowing is part of the beauty. It gives the mind room to breathe. So tonight we are not going to solve anything. We are not going to arrive at a final answer and close the book. Instead, we are going to build up the question slowly, piece by piece, like someone laying stones across a stream. We will start with what we can actually see, the part of the universe that our telescopes and instruments can reach. Then we will think about what the word edge even means when we are talking about all of space. And then, only then, we will look at the ideas people have dreamed up for what might lie beyond. Some of those ideas are careful scientific hypotheses, built on real mathematics. Others are more like philosophical daydreams, beautiful to think about but impossible to test. We will hold them all lightly, the way you might hold a smooth stone in your palm, turning it over to feel its shape, then setting it down again. The journey will take us through several rooms of thought. We will talk about the observable universe, which is the part we can see, and why it is not the same as the whole universe. We will talk about why there does not seem to be a wall or an edge anywhere we look. We will talk about the shape of space itself, which is a real thing you can measure, like finding out whether the ground beneath you is flat or curved. We will talk about whether the universe goes on forever, or whether it loops back on itself like the surface of a ball. And we will talk about the multiverse idea, which is the most famous guess about what might be outside, and also one of the most uncertain ideas in all of science. But all of that is ahead. Right now, we are just at the doorway. The only thing you need to do is lie there, in the dark, and let the words drift past. There is no exam at the end. No one will ask you to repeat anything back. The goal is not to remember. The goal is simply to rest, and to let your mind wander through some of the largest and gentlest thoughts we have. It is worth saying again, because it is so easy to forget. You do not need to follow every word. Sleep is the real destination here. If these words help you drift toward it, then they have done their work. If they simply keep you company in the quiet, that is enough too. There is no wrong way to listen. There is no failing at this. The question of what lies outside the universe is one of the most honest questions in science, precisely because it does not hide its uncertainty. Many questions in everyday life have clear answers. What time is it? Where did I leave my keys? Those questions close neatly. But the big questions, the ones that touch on the whole of existence, often refuse to close. They open outward. They lead to more questions. And that openness, that refusal to be pinned down, can feel deeply restful if you let it. There is nothing to grip, nothing to solve, just a wide, quiet space to wonder in. Some physicists spend their whole careers thinking about the shape and size and fate of the universe. They sit with these questions for decades. They make careful measurements of the light left over from the very early universe. They write equations that describe how space itself can bend and stretch. And after all that work, many of them will still tell you, quite calmly, that they do not know whether the universe is infinite or finite. They do not know what is outside it, or if outside is even a meaningful word. And they say this without embarrassment, without frustration. It is simply where the knowledge ends, for now. The maps run out, and beyond the maps, there is only the quiet of honest not knowing. That is the spirit we are going to move in tonight. Not the spirit of solving, but the spirit of sitting with. Not the spirit of grasping, but the spirit of letting be. If you feel your mind trying to hold on too tightly to an idea, see if you can loosen your grip. Let the idea float. Let it drift past like a cloud. Another one will come along soon enough, and you can watch that one too, and then let it go. We will move slowly. There is no rush. The universe has been here for something like 13.8 billion years, and it will be here long after we are gone. It can wait while you get comfortable. It can wait while your breathing slows. It can wait while you find the dark shape of sleep, waiting at the edge of your thoughts. So let's begin by just noticing the question itself. What is outside the universe? It feels like a natural question, a simple question. We are used to things having outsides. A house has an outside, a cup has an outside, the earth has an outside, a thin shell of atmosphere that fades into space. Everything we know has a boundary, a place where it stops and something else begins. So it feels reasonable to ask the same thing about the whole universe. Where does it stop? What is on the other side? Our minds reach for an edge, a wall, a border of some kind, because that is how we are built to think. We are creatures of edges and boundaries. We navigate a world of insides and outsides every day. But the universe may not work that way. And that is the first gentle shift we have to make. Not all at once, but slowly, over the course of the hour. The universe may not have an outside in the way a house does. It may not have an edge in the way a table does. The very ideas of edge and outside may start to break down when you apply them to the whole of space and time. That is not a failure of imagination. It is a recognition that the universe is not like the things inside it. It is the container, not the contained. And containers by their nature are hard to think about from the inside. Imagine a fish, if you like, swimming in the ocean. The fish knows water. The fish knows currents and temperatures and the shapes of coral. But if the fish could ask, what is outside the ocean, it would be asking a question its whole world had not prepared it for. The ocean is all the fish has ever known. The very idea of dry, or air, or sky is not just unknown, it is outside the framework of the fish's experience. We may be in a similar position, asking about the outside of the universe. The answer, if there is one, may involve concepts we do not yet have words for, dimensions we cannot feel, realities that do not fit inside our normal ways of thinking. But that does not make the question foolish. It makes it brave. It makes it deeply human. To ask what is outside the universe is to press gently against the walls of our own understanding, to see if they give. It is to admit that we are small, and the cosmos is vast, and that is a beautiful and humbling thing to admit. There is a kind of peace in that smallness. You, lying there in the dark, are a tiny warm point of awareness inside a universe so large it defeats easy description, and yet here you are, wondering about it. That is remarkable. That is worth noticing, just for a moment, before we let the thought go and sink a little deeper into rest. The plan tonight is simple. We will start close to home, with what we can actually see and measure. We will talk about light and how long it takes to travel, and why looking far away means looking back in time. That will give us the idea of the observable universe, the part we can reach with our instruments. It is a real, measurable sphere, about 93 billion light-years across. That number will come later, and we will sit with it for a while, because it deserves to be sat with. It is a big number. It is a number so big it stops meaning much, and becomes more like a feeling. The feeling of vastness, the feeling of being held inside something almost unimaginably large. From there we will move outward, or rather we will try to, and we will discover that the universe gives us no edge to push against. The maps do not run into a wall. They run into a horizon, a limit of what we can see, beyond which there is almost certainly more of the same. More galaxies, more stars, more space. And whether that space goes on forever, or whether it curves back around on itself like the surface of the Earth, is something we are still trying to figure out. The measurements so far suggest it is very close to flat, which would mean it could go on forever. But close to flat is not the same as perfectly flat, and the instruments keep getting better, and the question stays open. Then we will arrive at the biggest leap, the most speculative ground, the multiverse idea, the thought that our universe, vast as it is, might be just one bubble among many, or one region inside a larger inflating space, or one possibility among countless others. This idea is beautiful to contemplate, and many serious physicists take it seriously, but it is not a proven fact. It may never be provable. It sits right at the edge of what science can even ask, and it may cross over into philosophy, or into poetry, or into the quiet land where questions go, when they cannot be answered, only lived with. All of that is coming, but not yet. Right now, we are still in the doorway. The room is dark. The world outside your window is dark. The stars, if you could see them, are doing what they always do, burning slowly in the deep black, so far away that their light has been traveling toward us for years, or centuries, or millions of years. The light hitting your closed eyelids right now, if there is any, began its journey in some lamp or screen or sliver of moon, just a fraction of a second ago. Light travels fast, but it does not travel instantly. That small fact, the slowness of light measured against the scale of the cosmos, is one of the keys to everything we are going to talk about tonight. It is why we can see back in time. It is why we have a horizon. It is why the universe has a shape we can measure. But for now, just let that fact rest. Light is fast, but the universe is faster, or rather bigger, so much bigger that even light needs billions of years to cross it. That is a thought you can hold, or let go. It does not matter which. What matters in this moment is only that you are comfortable, that your breathing is slow and easy, that the knot of the day, if there was one, has begun to loosen. The question we are holding is not a knot to be untied. It is more like a smooth, cool weight in the palm of the mind. We can turn it over, we can feel its shape, we can set it down whenever we like. So welcome. The journey is starting, but it is a slow journey, a drifting journey, the kind you take with your eyes closed. Let the words come. Let them go. Sleep, when it comes, will be the destination, and everything else is just the path. So here we are, drifting together along that path. And the first thing we need to do, before we can ask what lies outside the universe, is to get clear on what we even mean by that word. Universe. It is a word we use all the time. We hear it in songs and in movies and in everyday conversation. But like many words that carry a lot of weight, it can mean different things depending on who is saying it and why they are saying it. If we are going to spend this hour wandering through some of the largest ideas humans have ever tried to think, we should start by being sure we know what we are pointing at when we say that single, heavy word. In ordinary life, when someone says the universe, they usually mean everything that exists. All of it. Every star, every planet, every galaxy, every speck of dust floating between them. every person, every thought, every moment of time that has ever happened or ever will happen. The whole sum of reality gathered up into one word. It is a word that leaves nothing out by definition. If you could somehow stand outside it and look in, which is exactly the thing we are wondering about tonight, you would see it all. That is the everyday meaning. The universe is the container that holds everything, and there is nothing outside it because everything already includes whatever might be out there. That definition is clean. It is complete. It is also, for our purposes tonight, not quite enough. Because when scientists talk about the universe, when cosmologists sit down to study it and measure it and write equations about it, they are often using the word in a slightly narrower, more careful way. They are talking about something specific and physical. They are talking about all of space and all of time, and all of the matter and energy those two things contain. That is still a lot. That is still almost everything. But notice the shift. The everyday definition is about everything that exists, which could include things we cannot even imagine, things outside space and time entirely. The scientific definition is rooted in space and time. It is rooted in the physical world we can, at least in principle, interact with. And that small shift, that quiet narrowing of the word, will matter a great deal when we start pressing on the edges of what we can know. Let me put it another way. When a cosmologist says the universe, they often mean the whole connected fabric of space-time that we are embedded in. They mean the thing that started expanding about 13.8 billion years ago in the event we call the Big Bang. They mean the thing that is still expanding today, stretching out in all directions, carrying galaxies away from each other. They mean the thing we can point our telescopes at and gather light from. That light, that physical information traveling through space, is the thread that ties the scientist's definition together. The scientific universe is the region that can, in principle, send us a signal. It is the region we can ever hope to learn anything about, because light or gravity waves or some other physical messenger can cross the space between there and here. This is where it gets subtle. The everyday definition says there is nothing outside the universe, because the universe is everything. The scientific definition says, well, there might be something outside the part of space and time we are connected to, but we cannot call it part of our universe because it is not in causal contact with us. Causal contact. That is a technical phrase, so let me unwrap it in the simplest way I can. Two things are in causal contact if something that happens in one place can affect something that happens in the other place. A light signal can travel between them. A ripple in space can reach from one to the other. They share a common physical history. If two regions are not in causal contact, then as far as physics is concerned, they might as well be in separate worlds. Nothing that happens in one can ever be known or felt in the other. They are disconnected, not by a wall, but by the sheer stretch of space and time. So already, just by defining our terms, we have opened up some breathing room. The universe, in the scientific sense, is not necessarily all of existence. It is the part of existence we are physically connected to. It is the part we can see, or could ever hope to see, or could ever be touched by. And this means that asking, what is outside the universe, is not the same as asking, what is outside everything that exists. It is more like asking, what is outside the part of everything that we are connected to, and that is a question that might actually have a scientific answer, or at least a scientific conversation around it. It is a question we can approach with measurements and theories, rather than just with philosophy. Now, there is another piece of vocabulary we need to settle into before we go much further, and that is the idea that space itself is a real, physical thing. This is one of those shifts in understanding that took humans a long time to make, and it still feels a little strange if you sit with it. Most of us grow up thinking of space as empty nothingness. It is the blank background that everything else sits in. You have a room, and the room is mostly empty space, and you put furniture in it. You have the night sky, and it is mostly empty space, and you put stars in it. Space, in this everyday picture, is just the absence of stuff. It is what is left when you take everything else away. It is the stage, not an actor. It is the blank page, not the writing. But that picture turns out to be wrong, or at least it turns out to be incomplete. One of the great discoveries of the last century is that space is not just a passive background. It is a thing. It has properties. It can bend, it can stretch, it can ripple, like the surface of a pond. It can expand, which is exactly what it has been doing for the last 13.8 billion years. When we say the universe is expanding, we do not mean that galaxies are flying outward through a fixed empty space, like shrapnel from an explosion. We mean that space itself is being created between them. The fabric is stretching. The distance between things is growing, not because the things are moving, but because the ground beneath them is swelling. This is a hard idea to picture, and if it does not come easily to you, that is not a failing of your imagination. We are evolved to think about rocks and rivers and the space between trees. We are not evolved to think about the fabric of reality stretching, so do not worry if the image stays a little fuzzy. The important thing to take away is simply this: space is not nothing. It is a something. It is a real, dynamic, physical part of the universe, just as real as matter and energy. In fact, one way to think about modern physics is that it treats space and time and matter and energy as different expressions of the same underlying reality. They are all woven together. You cannot have one without the others. To make this a little easier to hold in the mind, some people like to use the image of a fabric. Imagine a vast, smooth sheet of soft cloth, stretching out in all directions as far as you can imagine. That cloth is space itself. Now imagine that stitched into that cloth, or perhaps painted onto it, are all the stars and galaxies and clusters of galaxies we know. They are not sitting on the cloth like objects on a table. They are part of the cloth. They are patterns in the weave. When the cloth stretches, the patterns move apart, not because they are sliding across the surface, but because the surface they are made of is getting bigger. That is the picture to hold. Space is the fabric the whole story happens on, but it is also part of the story. It is not just the stage, it is woven into the play. This idea will matter a great deal later, when we start talking about the shape of space and what it means for the universe to be curved or flat. Because if space is a real physical thing, then it can have a shape in the same way a real physical sheet can have a shape. A sheet of paper can lie flat. The surface of a ball is curved. A saddle is curved in a different way. And if space itself can be curved, then the whole question of what is outside the universe starts to twist into new and unfamiliar shapes. An edge, after all, is something a flat sheet can have. A sheet of paper has 4 edges, but the surface of a ball has no edge. An ant walking on the surface of a ball can walk forever and never fall off, never reach a boundary, never find a place where the surface just stops. If our universe is like the surface of a ball, only in more dimensions, then the question of what is outside it might not be answerable in the way we think. But that is getting ahead of ourselves. We will arrive there in time. For now, the thing to hold on to is simply this distinction. There is the everyday universe, which is everything that exists, full stop. And there is the physical universe, which is the connected fabric of space and time and matter and energy that we are embedded in. When cosmologists study the universe, they are studying this second thing. They are studying the great stretching fabric and all the light and matter woven into it. And when they ask what is outside it, they are asking whether that fabric has an edge, or whether it goes on forever, or whether it connects back on itself, or whether there are other fabrics entirely, disconnected from our own. That is the vocabulary we will be using for the rest of the night. It is simple vocabulary, really, just a few careful distinctions, but with those distinctions in place, the path ahead becomes a little clearer. We can start to ask sharper questions. How big is the part we can actually see? What is the shape of the fabric? Does it have a boundary? These are questions we can take measurements on. These are questions with real, physical answers, even if some of those answers are still unknown. So let the words settle for a moment. The everyday universe, everything that is. The physical universe, the fabric of space-time we live in. Space as a real, stretchable thing, not just emptiness. These are the building blocks we will carry forward. They are simple blocks, but they are strong enough to support a great deal of careful thought. And the beautiful thing is, you do not need to grip them tightly. They will be here when you need them, quietly doing their work in the back of your mind. If you are already feeling the pull of sleep, that is fine. That is more than fine. The fabric can stretch without you watching it. The universe can expand without you tracking every detail. You can let go, and the words will keep moving softly forward, a quiet stream in the dark. Where we go next is toward the light, toward what we can actually see from our small, warm point here on this small, warm planet. We have a working definition now. We have a sense that space is a real thing. The next natural question is, how much of that real thing can we look at? How far does our view reach? And what do we find when we look as far as we possibly can? That is the question of the observable universe, and it is where we will drift next, following the path at whatever pace feels right. And so we drift toward the light, just as promised, toward what we can see, toward the part of this great stretching fabric that our instruments can reach, that our telescopes can gather, that our eyes, if they were sensitive enough, could take in. This is the ground we can actually stand on, scientifically speaking. The rest, the beyond, the outside, all of that will come later. But first, the measurable. First, the known. There is a fact about light that is so simple and so profound that it shapes almost everything we understand about the cosmos. Light travels fast, but it does not travel instantly. This is something we know in our bones, even if we do not think about it every day. When you see a flash of lightning far away, you count the seconds until the thunder comes. The light reaches you almost at once, but the sound takes its time. Light is faster than sound, vastly faster, but it is still not infinite. It takes time to cross a room. It takes time to cross a field. It takes time to cross the spaces between stars. And it takes time, enormous amounts of time, to cross the spaces between galaxies. The speed of light is a fixed number. In the empty vacuum of space, light travels at about 186,000 miles every second. That is fast enough to circle the Earth more than 7 times in a single heartbeat. It is fast enough that, on the scale of our daily lives, it might as well be instant. When you turn on a lamp, the room fills with light so quickly you cannot perceive any delay at all. But the universe is not built on the scale of our daily lives. The universe is built on a scale so vast that even light, racing at its impossible speed, takes years to travel between neighboring stars, and thousands of years to cross a single galaxy, and millions of years to cross the gaps between galaxies, and billions of years to reach us from the farthest things we can see. This means that looking far away is the same thing as looking back in time. This is such a central idea that I want to say it again, more slowly, with a picture to help it settle. Imagine you are standing on a hill, looking out across a wide valley. On the other side of the valley, a friend lights a match. You do not see the match the moment it is lit. You see it a tiny fraction of a second later, because the light from the match has to cross the valley to reach your eyes. The delay is too small for you to notice, but it is real. Now stretch that valley. Stretch it until it is not a valley but the space between stars. The match is a star burning bright. The light from that star takes years to reach you. When you look up and see that star, you are not seeing it as it is right now. You are seeing it as it was when the light left it, years ago. You are looking into the past. Every time we look at the night sky, we are looking back in time. The moon we see is the moon as it was about 1¼ seconds ago. The sun we see, though we should never look directly at it, is the sun as it was about 8 minutes ago. The nearest star beyond our sun, a star called Proxima Centauri, appears to us as it was a little over 4 years ago. The bright band of the Milky Way, stretching across the sky, is a river of time as much as a river of stars. Some of those stars are thousands of years in the past. Some are tens of thousands. The light entering your eye, if you were standing under a dark sky right now, began its journey before there were cities, before there were farms, before the last ice age ended, before humans had spread across the earth. And we can look deeper still. With telescopes, we can see galaxies whose light has been traveling toward us for millions of years, for hundreds of millions of years, for billions of years. The deepest images ever taken show us galaxies as they were when the universe was young, when it was a fraction of its current age. Their light set out across space long before our sun was born, long before the Earth formed, long before the raw materials of our solar system had even been gathered together. We are seeing them as they were more than 13 billion years ago. That light is a message from a time very close to the beginning. This is what gives us the idea of the observable universe. The observable universe is simply the region of space whose light has had enough time to reach us since the very beginning of things. Since the Big Bang, if you want to use that name, though we will talk more about what that name really means later on. The universe began about 13.8 billion years ago. That is our best current measurement, refined over decades of careful work. And because light travels at a fixed speed, there is a limit to how far we can see. Any object whose light would take longer than 13.8 billion years to reach us is simply invisible. Its light has not arrived yet. It is beyond our sight. Not because it is hidden behind something, not because it is in another dimension, but because there has not been enough time since the universe began for its light to cross the distance. That sounds simple. A sphere of visibility centered on us, with a radius in light years equal to the age of the universe in years. 13.8 billion light years out, in every direction. But the real number is larger, and the reason it is larger touches on the stretching of space we talked about earlier. While the light has been traveling toward us, the space behind it and ahead of it and all around it has been stretching. The universe has been expanding the whole time. So the object that emitted that light long ago is now much farther away than it was when the light set out. When we do the full calculation, accounting for the expansion of space, the observable universe turns out to be roughly 93 billion light-years across. Not 13.8 billion, 93 billion. That is a real number, a measured number, as well as we can measure such things. The observable universe, the sphere of space we can in principle see, is about 93 billion light-years from one side to the other. Let that number just sit in the room with you for a moment. 93 billion light-years. A light-year, just to be sure we are holding it right, is the distance light travels in 1 year, about 6 trillion miles. Multiply that by 93 billion, and you get a number so large it stops being a number and becomes more like a feeling. The feeling of vastness, the feeling of being very small, held inside something very large. And yet this is just the part we can see. This is just the bubble of light that has reached us. It is our local patch, our visible neighborhood, our small window onto the whole. And here is the crucial point, the one that will carry us into the next part of our journey. The edge of the observable universe is not a physical edge. It is not a wall. It is not a boundary where space stops. It is simply a horizon, like the horizon you see when you stand on a beach and look out at the ocean. The horizon is not the edge of the ocean. It is just the limit of how far you can see, because the earth curves away from you. If you got in a boat and sailed toward the horizon would move with you. You would never reach it. You would simply find more ocean. The observable universe is like that. It is a horizon of time, not of space. It is the limit of how far back in time we can see, because beyond that point, there has not been enough time for light to reach us. If you could magically travel to a galaxy near the edge of what we can observe, the inhabitants of that galaxy, if there were any, would see a different observable universe. Their bubble of light would be centered on them, not on us. They would see regions of space we cannot see, and we see regions they cannot see. Neither of us sees a wall. We both just see more universe. This is a deeply restful thought, if you let it be. The limit of our sight is not a limit of reality. It is just a limit of our particular viewpoint, our particular location in space and time. The universe does not end where our vision ends. It almost certainly continues, on and on, in every direction, far beyond the 93 billion light-year sphere we can detect. How far it continues, and what shape that continuation takes, are the questions we will sit with next. But for now, just hold this one thought. We live inside a bubble of visibility. That bubble is real, and it is measurable, and it is vast beyond easy imagining. But it is not a cage. It is not a room with walls. It is just the part of the universe that has had time to send us its light. Beyond it, there is almost certainly more of the same. More galaxies, more stars, more space, more time. Let me say that number one more time, not to fix it in your memory, but to let it drift across your mind like a cloud. 93 billion light-years. That is the width of the part of the universe we can see. It contains, by our best estimates, something like 2 trillion galaxies. Not stars, galaxies. Each galaxy containing hundreds of billions of stars. Each star, perhaps, hosting its own worlds. It is a number so large that the mind, wisely, gives up trying to picture it. And that giving up is not a failure. It is a kind of release. You do not need to hold 93 billion light-years in your head. You can just let it be large. You can let the weight of it press gently against your awareness, and then you can let it go. The beauty of the observable universe as a concept is that it is grounded in something we can all understand. The slowness of light. The fact that information takes time to travel. We experience this in tiny ways every day. In the lag of a video call, in the echo of thunder after lightning. The universe simply scales that lag up to cosmic proportions. It takes the same principle and stretches it across billions of years, and by doing so, it gives us a window into the past. Every time we look up, we see the history of things written in light. The oldest light we can see, the light that forms the faint glow we call the cosmic microwave background, is light that has been traveling for almost the entire age of the universe. It comes to us from a time when the universe was only about 380,000 years old, a hot, dense fog just beginning to clear. That light is the edge of our observable bubble. It is as far back as we can see, not because there is nothing before it, but because before that time, the universe was so hot and dense that light could not travel freely. It was scattered, absorbed, blocked. The cosmic microwave background is the moment the fog lifted. It is our horizon in time. And beyond that horizon, in space, there is more. There must be more. There is no reason to think the universe just stops there. Every measurement we have ever made tells us the universe is the same in all directions, on the largest scales. It is smooth. It is uniform. There is no sign of an edge, no sign of a boundary, no sign that we are anywhere special. We are just here, on this small, warm planet, inside this vast bubble of light, and the bubble is not the whole story. It is just the part we can read so far. So rest with that, if you like. The observable universe, a sphere of visibility, a horizon of time, 93 billion light-years of stars and galaxies and light, and beyond it, more. The fabric stretches on. The next question, the one waiting just ahead, is what happens when we press against that horizon in our minds? Do we find a wall? Do we find an edge? Or do we find, as the evidence suggests, simply more of the same, continuing onward, curving perhaps, but never stopping? That is where we are going next. But not yet. For now, just the light, just the long, slow journey of photons across the deep. Just the quiet knowledge that looking out is looking back, and that the farthest thing we can see is a kind of dawn, the first clear light of a universe just beginning to become transparent. Hold that image if it comforts you. Let it go if it does not. Sleep is still the destination. Everything else is just the path. We have arrived at a strange place in our drifting journey. We have seen that the observable universe is a bubble of light, a sphere of visibility, about 93 billion light-years across. We have seen that this bubble is not the whole of things, only the part whose light has had time to reach us. And now, standing at the edge of that bubble in our minds, we run into a very natural, very human instinct. The instinct to imagine a wall, the instinct to picture the universe as a giant room, and the edge of the observable universe as its boundary, and beyond that boundary, some kind of outside. Maybe a void, maybe a nothing, maybe something else entirely, but a boundary nonetheless, a place where the universe stops. This instinct is old. It is woven into the way we experience the world. Everything we know has an edge. The bed you are lying on has edges. The room around you has walls. The earth beneath us, though it feels endless when we stand on it, has a surface, a crust, a place where the ground stops and the sky begins. We are creatures of boundaries. We navigate a world of insides and outsides, of containers and contained things. So when we hear about the universe, when we hear about the farthest things we can see, the mind naturally reaches for that same picture, a giant container, a cosmic room, a wall, somewhere far away, marking the end of everything. But that picture, as natural as it is, does not seem to match the actual universe we live in. The evidence we have gathered, across decades of careful observation, points in a different direction entirely. There is no wall, there is no edge, there is no sign of a boundary anywhere we look. And this absence is not a failure of our instruments. It is not a gap in our knowledge that we hope to fill someday. The absence of an edge is itself a real piece of information. It is a finding. It is something we have learned about the nature of space and time. Let me say that again, because it is easy to miss its importance. We have looked for an edge, not with our eyes alone, but with every tool we have. We have mapped the positions of galaxies across vast stretches of the sky. We have measured the afterglow of the Big Bang, the cosmic microwave background, in exquisite detail. We have studied the way the universe expands, the way matter is distributed, the way light bends around large clusters of galaxies. And in all of that looking, in all of that measuring, we have found no indication that space simply stops somewhere. No wall, no boundary, no sign that the universe has a physical edge. If there were an edge, it would show up in our measurements. A boundary to space would be a very strange and noticeable thing. It would break the smoothness we see. It would create a special direction, a special place. The universe around us would not look the same in every direction if one of those directions ended at a wall. But the universe does look the same in every direction, on the largest scales. It is smooth. It is uniform. It is, as cosmologists sometimes say, homogeneous and isotropic. Those are technical words, but they mean something simple. Homogeneous means the universe is roughly the same everywhere you go. Isotropic means it looks roughly the same in every direction you look. No special places, no special directions, no edges. So the instinct to imagine a wall, while perfectly understandable, leads us astray. The universe is not a room. It is not a box. It is not a giant sphere with a surface you could touch, if only you could travel far enough. The edge of the observable universe is a horizon, not a wall. It is a limit of time and light, not a limit of space. And beyond that horizon, everything we know suggests that space simply continues. There is an old story, perhaps more of a parable, that helps with this shift in thinking. Once, long ago, sailors feared that if they traveled too far from shore, they would fall off the edge of the world. The earth, they believed, was flat, a great disk of land and water, and somewhere out in the ocean, the disk ended. Sail beyond that point, and you would plunge into the void. This was not a foolish belief, given what they knew. The horizon on a flat earth looks like an edge. The world around them seemed flat. Every local measurement they could make suggested flatness. It took a leap of imagination, and later a great deal of evidence, to realize that the earth was not a flat disk but a sphere. And on a sphere, there is no edge. You can walk forever and never fall off. You will simply, eventually, return to where you started. The horizon is not a boundary, it is just the limit of your view, caused by the curvature of the surface you stand on. The universe may be like that. We may be like those ancient sailors, standing on the shore of our small planet, looking out at a horizon we mistake for an edge. The universe may not be a flat expanse that ends somewhere. It may be curved, continuous, finite perhaps, but unbounded. Or it may be flat and infinite, going on forever in all directions. In neither case is there a wall. In neither case is there a place where space just stops. The fear of falling off the edge of the world turned out to be based on a misunderstanding of the Earth's shape. The fear of finding an edge to the universe may turn out to be based on a similar misunderstanding of the shape of space. This is a gentle thought, I think. It means that the universe is not a cage. It is not a container with hard walls pressing in. It is something more subtle, more flowing, more continuous. Space is not a room we are trapped inside. It is a fabric we are woven into, and that fabric may simply go on, without seam or border, far beyond anything we can see or ever will see. The absence of a wall is not a mystery to be solved. It is a property of the universe we live in. It is a feature, not a bug. It is part of the deep structure of things. And yet the mind still wants to ask, but what is beyond the continuation? If space goes on forever, what is it expanding into? If space curves back on itself, what is on the other side of the curve? These are natural questions. They are the same questions the sailors might have asked. What is under the sphere? What holds it up? And the answer, in the case of the Earth, was a radical shift in framework. The Earth does not need to be held up. It floats in space, held in orbit by gravity. The question, what holds it up, assumed a framework of up and down that did not apply. In the same way, the question, what is beyond the universe, may assume a framework of inside and outside that does not apply. We will sit with that possibility more deeply in a later section. For now, just notice the absence. No wall, no edge, no boundary, just a horizon, and beyond it, almost certainly, more of the same. This is what the data tells us, as clearly as data can tell us anything. The cosmic microwave background, that faint glow of the earliest light, is smooth to about 1 part in 100,000. That means the temperature of the universe, when it was very young, was the same in every direction to within a tiny fraction of a degree. If the universe had an edge, if space just stopped somewhere, that smoothness would be very hard to explain. An edge would be a special place. It would have different properties than everywhere else. It would leave a mark on the light that passed near it. We see no such mark. The light is smooth. The universe is smooth. The fabric continues. This smoothness also tells us something else, something we will explore more in the next section. It tells us that the universe is very likely connected. Regions of space that are far apart today, so far apart that light could never have traveled between them, were once close together, close enough to mix and equalize. This is one of the great puzzles that the theory of cosmic inflation tries to solve, and we will come to that in time. But for now, the point is simply that the universe we see is all of a piece. It is one continuous fabric. There is no tear, no seam, no edge. It is all one thing, stretching from here to the limit of our sight and beyond. So if you find your mind, as you drift towards sleep, reaching for the image of a cosmic wall, a great dark barrier at the end of everything, see if you can let that image soften. Let it become a horizon instead, a line that moves with you, that recedes as you approach, that is always just out of reach. The horizon on the ocean is not a wall, it is a trick of the Earth's curve and the limits of your eyes. The horizon in space is not a wall, it is a trick of time and the finite speed of light. Both horizons are real, both mark a genuine limit to what you can see, but neither marks the end of what is there. This is one of those shifts in thinking that can feel restful once it settles in. The universe is not a small, bounded thing that we are trapped inside. It is vast and open, without edges, without boundaries, without anything you could bump into if you traveled far enough. It is a wide, calm sea of space, stretching away in every direction, and we are small boats on its surface, drifting. The horizon stays always around us, a circle of light we cannot see beyond. But the sea itself does not end at the horizon. It just goes on, wave after wave, galaxy after galaxy, into a distance we can only imagine. And what of the void, the nothingness we sometimes picture beyond the edge? If there is no edge, then there is no void waiting on the other side. The universe is not a bubble of something floating in an ocean of nothing. The universe is the whole fabric, and if the fabric goes on forever, then there is no nothing. There is only more something, more space, more time, more of the same smooth, expanding, star-filled fabric we are part of. The idea of a void outside may be as mistaken as the idea of a wall at the edge. We will circle back to this when we talk about what outside even means. But for now, just let the wall dissolve. Let the boundary soften into a horizon. Let the universe become, in your mind, what the evidence suggests it is, a continuous, unbroken, edgeless whole. There is a quiet comfort in this, I think. An edgeless universe is a universe without a hard stop. It is a universe that does not press in on you. It is a universe where there is always more to see, more to explore, more space unfolding ahead of you, even if you can never actually cross it. It is a universe that breathes, a universe that does not confine. And if you are lying there in the dark, feeling the walls of your room around you, it can be restful to know that beyond those walls, beyond the sky, beyond the farthest galaxy, there is no great wall waiting, just more room, just more space, just the quiet, continuous fabric of things, stretching away without end. We will go further into this. The next step is to ask what shape that continuous fabric has. Is it flat, like an endless sheet? Is it curved, like the surface of a ball? Is it something stranger still? That is the question of the shape of space, and it is one of the most carefully measured questions in all of cosmology. But for now, we can pause here, at the dissolving of the wall. We can let the old picture fade, the picture of a cosmic room with cosmic walls, and let the new picture settle in its place. A horizon, not a wall. A continuation, not a stop. An edgeless fabric, carrying us along with it as we drift deeper into the dark. Now we come to the shape of the whole thing. The shape of the fabric we have been speaking about, the great stretching cloth of space itself. This is not a metaphor, or not only a metaphor. It is a real, measurable property of the universe we live in. Space can have a shape. It can be flat or it can be curved. And the shape it has determines a great deal about how the universe behaves, how it will evolve, and whether it is infinite or finite. So let us settle into this idea slowly, because it is one of the most important ideas in all of cosmology, and also one of the most beautifully simple once you find your footing. We are used to thinking of shapes as things objects have. A ball has a shape, a table has a shape, a leaf has a shape, but we are not talking about the shape of an object inside space. We are talking about the shape of space itself, the fabric, the background, the thing that contains everything else. To get a feel for this, start with something familiar. Imagine a flat sheet of paper, stretching out in all directions. The paper is perfectly smooth, no bumps, no ripples. This is what scientists mean when they talk about flat space. It is space where the rules of geometry you learned in school apply exactly. Parallel lines stay parallel forever. The angles of a triangle add up to 180 degrees. If you draw two lines that start out going the same direction, they will never cross. That is flat space. It is simple. It is intuitive, and it is, as far as we can measure, very close to the space we actually live in. But space does not have to be flat. It can be curved, and curved space behaves differently. The easiest curved shape to imagine is the surface of a sphere, the surface of a ball, say, or the surface of the Earth. On the surface of a sphere, the rules of flat geometry break down. Parallel lines, if you try to draw them, eventually cross. The angles of a triangle add up to more than 180 degrees. If you start walking in one direction and keep going straight, you will eventually come back to where you started. The surface is finite, but it has no edge. You can walk forever and never fall off. This kind of curvature is called positive curvature because it curves outward, like the top of a dome. In a positively curved universe, space bends back on itself. It is closed, like the surface of a sphere, but in 3 dimensions instead of 2. Hard to picture, but the mathematics is clear. There is also the opposite kind of curvature. Instead of curving outward like a sphere, space could curve inward, like a saddle, or like a mountain pass between 2 peaks. This is called negative curvature. On a negatively curved surface, parallel lines spread apart. The angles of a triangle add up to less than 180 degrees. If you start walking in one direction, you never come back to where you started. You just keep going, getting farther and farther away. A negatively curved universe would be infinite in extent, stretching on forever in all directions, with a strange, saddle-like geometry that gets harder to visualize the more you think about it. These 3 possibilities, flat, positively curved like a sphere, and negatively curved like a saddle, are the 3 simplest shapes the universe could have. There are others, more complicated shapes that involve loops and twists and connections in higher dimensions. But these 3 are the starting point. They are the first candidates scientists check when they look at the data, and the question of which one describes our universe is not a matter of philosophy or preference. It is a question that can be answered by measurement, by looking at the light, by looking at the afterglow of the Big Bang. The cosmic microwave background, that faint light we spoke of earlier, is the key. It is the oldest light we can see, released when the universe was only about 380,000 years old. Embedded in that light is a pattern of tiny temperature differences, spots that are slightly warmer and spots that are slightly cooler. These spots have a characteristic size. They were formed by sound waves rippling through the hot early universe, and the size of the largest spots tells us something about the geometry of space. If space is flat, the spots will appear to us at a certain angular size. If space is positively curved, like a sphere, the light rays will be bent, and the spots will appear larger. If space is negatively curved, like a saddle, the spots will appear smaller. This is a beautiful piece of science. It means that by carefully measuring the size of these ancient spots in the sky, we can learn the shape of the entire universe. It is like looking at a single ripple on a pond and deducing the shape of the whole Earth. The measurements have been made by satellites and ground-based telescopes with extraordinary precision, and what they show is this. The spots are very close to the size you would expect in a flat universe. The curvature, if there is any, is so slight that our current instruments cannot detect it. The universe, as far as we can tell, is flat. Let me say that again, because it is one of the most important findings in modern cosmology. The observable universe, the part we can see, is very close to perfectly flat. The angles of the largest triangles we can draw, triangles that span billions of light years, add up to 180 degrees within the margin of error. Parallel lines, as far as we can trace them, do not cross or spread apart. The geometry of the universe, on the largest scales, is the simple, straight geometry of a flat sheet of paper. This does not mean the universe is shaped exactly like a sheet of paper. It means that the 3-dimensional space we live in obeys the rules of flat geometry. A flat 3-dimensional space is harder to picture than a flat 2-dimensional sheet, but the idea is the same. In a flat 3-dimensional space, if you point 3 laser beams in 3 directions that are all at right angles to each other, they will stay at right angles forever. The space will not bend them toward or away from each other. That is what flat means. It is a statement about how space behaves, not about how it looks from the outside. And here is a crucial point, one that often causes confusion. A flat universe does not mean a bounded universe, like a flat sheet of paper with edges. A flat universe can be infinite. It can go on forever in all directions, never curving back on itself, never reaching a boundary. The sheet of paper, in the mind's eye, has edges, but that is because we are picturing a finite sheet. A flat universe does not need to have edges. It can simply continue, without limit, in every direction you could ever travel. Flat and infinite go together naturally in the simplest models. This is where the question of the shape of space starts to open up into something even larger. If the universe is flat, it could be infinite, but it could also be finite if it has a more complicated shape, a shape that is flat but still loops back on itself. Think of a video game where if you go off the right side of the screen, you come back on the left side. The space in that game is flat, in the geometric sense. Parallel lines stay parallel, but it is finite and it has no edge. The universe could be like that, wrapped around itself in a way we cannot directly perceive. We will sit with that idea more in the next section. For now, let it just be a possibility, a quiet asterisk next to the word flat. The measurements that tell us the universe is close to flat come mostly from a satellite called Planck, which spent years mapping the cosmic microwave background in fine detail. The data from Planck, combined with other observations of how galaxies are distributed and how the universe is expanding, all point in the same direction. The universe is flat, or so close to flat that the difference is smaller than our instruments can detect. The curvature, if it exists, is less than about 1 part in 250. That is a very small number. It means that if the universe is a sphere, it is a sphere so vast that the part we can see, the 93 billion light-year bubble, is only a tiny patch on its surface. Like an ant on a beach ball so large it looks flat to the ant. The ant measures and finds no curvature, not because the curvature is not there, but because the ball is just that big. That is an important reminder. When scientists say the universe is flat, they mean it is consistent with being flat, given our current measurements. They do not mean it is proven to be perfectly flat, with no curvature at all, down to the last decimal place. Perfect flatness would be a very strange thing, mathematically speaking. It would be a special case, a single value among a range of possibilities. The universe could have any amount of curvature, from strongly positive to strongly negative. That it appears to be so close to flat is a puzzle, one that the theory of cosmic inflation helps to explain. We will get to inflation soon, but for now, just hold the finding. The universe is very, very close to flat, so close that, for most practical purposes, we can treat it as flat. This flatness has consequences. A flat universe will expand forever, slowing down gradually, but never stopping and never collapsing back on itself. A positively curved universe, like a sphere, would eventually stop expanding and begin to contract, ending in a kind of reverse Big Bang, sometimes called a Big Crunch. A negatively curved universe would expand forever, and at a faster rate than a flat one. The fact that our universe appears flat means it sits right on the boundary between these fates. It will expand forever, coasting outward, growing colder and darker over unimaginable spans of time. But that is another story, for another night. Tonight we are focused on the shape, and on what the shape tells us about the question of what is outside, because the shape is the deepest clue we have. If the universe is truly flat and infinite, then there is no outside. There is just more of the same, forever. Every point has space stretching away from it in all directions without end. There is no boundary, no edge, no place where space stops and something else begins. The question, what is outside, would have no answer. Not because the answer is hidden, but because there is no outside. The framework of inside and outside, which works so well for objects within the universe, breaks down when applied to the whole. If the universe is flat but finite, wrapped around itself in some higher dimensional way, then there is also no outside. A traveler who went far enough in one direction would return to their starting point, like a circumnavigation of the Earth. The universe would be a closed loop, but a flat one, with no edge and no outside. This is harder to picture, but it is a real mathematical possibility, and scientists have looked for signs of it in the cosmic microwave background, searching for repeating patterns that would indicate a wrapped-around space. So far, no such patterns have been found. The universe, if it is wrapped around itself, is wrapped on a scale larger than the observable part. And if the universe is positively curved, like a sphere, then it is finite but still without an edge. The surface of a sphere has no boundary. You can walk forever and never fall off. A three-dimensional spherical universe would be the same. It would be finite, containing a certain total volume of space, but it would have no edge, no boundary, no outside. In all three cases, flat and infinite, flat and wrapped, or curved like a sphere, the answer to what is outside is the same. There is no outside. The universe is all there is, and it is complete in itself. This is the shape of things, as best we can measure. A flat or nearly flat fabric, an edgeless whole, a geometry that points toward infinity, or toward a finitude so subtle we cannot detect it. The question of the shape of space is not fully settled. It remains an active area of research, with new measurements being planned and new theories being developed. But the broad picture is clear. The universe is not a box. It is not a bubble floating in a void. It is a smooth, continuous, edgeless fabric, and we are small patterns woven into it, drifting along with the stretch. Let the words settle if they need to. Flat, curved, sphere, saddle. These are just shapes after all, shapes you have known since you were a child. The universe, for all its vastness, may be describable by the same simple geometry you learned in school. That is a restful thought in its own way. The same rules that govern a triangle drawn on paper govern the largest structures we can see. The universe is not alien, it is not beyond understanding. It is made of the same mathematical cloth, stretched wide. And now we must sit with what that flatness implies. If the universe is flat, it could be infinite. Infinite is a word that does heavy lifting. It is a word the mind bounces off of. It is a word that changes the question of what is outside into something else entirely. So that is where we will go next, into the honest uncertainty, into the question of whether the universe goes on forever, or whether it loops back, or whether the question itself is one we are not yet equipped to answer. The path continues, the fabric stretches on, and we drift with it, slowly, into the next quiet room of thought. And so we arrive at one of the largest and most honest questions in all of science. Is the universe infinite, or is it finite? Does it go on forever, without end, in every direction? Or does it have a total size, a final volume, a limit to how much space there is? This is not a question about what we can see. It is a question about what is. And the answer, as of now, as of this moment in the long, slow history of human understanding, is that we do not know. We do not know if the universe is infinite or finite. That is the plain truth. It is not a failure. It is not a gap that scientists are embarrassed by. It is simply where the evidence runs out, where the measurements become too faint, where the mathematics offers multiple possibilities, and nature has not yet told us which one she chose. We do not know yet is a real, respected answer in cosmology. It is an answer that holds the door open. It is an answer that invites more looking, more measuring, more thinking. It is an answer that breathes. Let us sit with that for a moment. We do not know if the universe is infinite. The word infinite itself is a hard word. It does not just mean very big. The observable universe is very big. 93 billion light-years across is very big. 2 trillion galaxies is very big. But very big is not infinite. Infinite means no end. Not a distant end. Not an end beyond what we can see, but no end at all. It means that if you could travel in a straight line, faster than light, for any amount of time, you would never reach a boundary. You would never run out of new places. There would always be more galaxies ahead of you, more stars, more space, stretching on without limit. That is what infinite means. And it is a genuine possibility for the universe we live in. It is also possible that the universe is finite. Finite means there is a total amount of space, a total volume. If you could somehow step outside and look at the whole thing, it would have a definite size, like a ball has a definite size. But finite does not mean it has an edge. This is the subtle point we touched on earlier, and it is worth dwelling on now. A finite universe does not need a boundary. It can be finite and still edgeless. The classic image, the one that has been used for a century to help people hold this idea, is the surface of a sphere. The surface of a sphere is finite. It has a certain number of square miles. You can measure it, but it has no edge. An ant walking on the surface of a ball can walk forever and never fall off, never reach a boundary, never find a place where the surface just stops. The ant's world is finite, but it is unbounded. Our universe could be the same, only in 3 dimensions instead of 2. In a finite spherical universe, if you set off in a straight line, you would eventually, after a very long time, return to your starting point. Not because you turned around, but because space itself curved back on itself. The straight line would become a great circle, like the equator on the Earth. You would circumnavigate the cosmos. This is a beautiful idea, and it is one that scientists have looked for evidence of. If the universe were small enough, we might see the same galaxies in opposite directions in the sky. Light from a single galaxy could travel around the curve and reach us from the other side. We would see repeating patterns, like a hall of mirrors. So far, we see no such patterns. If the universe is a sphere, it is a sphere larger than the part we can see. The curvature is too gentle for us to detect, and the total size is at least several times larger than the observable bubble. But a spherical universe is not the only way to be finite and edgeless. There are stranger shapes, shapes that are flat but still finite. Imagine a flat sheet of paper, but imagine that the left edge is glued to the right edge, and the top edge is glued to the bottom edge. If you walk off the right side, you appear on the left side. If you walk off the top, you appear on the bottom. This is the shape of a donut, mathematically speaking, though the donut is not the shape of the space itself. The space is flat, the geometry is flat. Parallel lines stay parallel. Triangles add up to 180 degrees, but the space is wrapped around itself, connected in a loop. This is called a torus, and it is one of many possible finite flat shapes the universe could have. The technical name for these shapes is topologies, but that word is not important for our purposes. What matters is the idea, a flat space that loops back on itself, finite volume, no edges, no curvature. Could our universe be like that? Could it be a vast, flat, wrapped-around space, larger than the observable part, so that we cannot see the repeating patterns? Yes, it is possible. Scientists have searched for signs of such a topology in the cosmic microwave background, looking for circles that match circles on the other side of the sky, indicating that light has wrapped around the universe. So far, no such circles have been found. The universe, if it is wrapped on a scale larger than about 90% of the observable diameter. The loops are too big for us to see. The hall of mirrors is too vast for the reflections to reach us. And then there is the simplest possibility of all. The universe is flat and infinite. It just goes on forever. No curvature, no wrapping, no loops, just an endless, flat expanse of space, filled with galaxies and stars and whatever else the cosmos contains. This is the picture that most naturally falls out of the measurements. The universe appears flat, and a flat universe, in the simplest models, is infinite. There is no mathematical requirement that it be infinite, as the wrapped shapes show, but infinity is the default. It is the simplest assumption, and it is an assumption that has a certain calm to it. An infinite universe has no outside. It has no edge. It has no boundary where something else begins. It is complete in itself, everywhere, forever. But we do not know. That is the refrain of this section, and I want to return to it gently, like a chorus in a lullaby. We do not know. The measurements are consistent with flatness, but they are also consistent with a very slight positive curvature, or a very slight negative curvature. They are consistent with a flat, infinite universe, and they are consistent with a flat, wrapped universe larger than the observable part. The data does not pick one, The data says, all of these are possible. Keep looking, keep measuring. The question stays open. This is the honest uncertainty at the heart of cosmology. It is not a weakness, it is a strength. Science is not a collection of answers. It is a process of asking and measuring and asking again and refining and holding the open questions carefully, like fragile things, until the evidence is strong enough to close them. The question of whether the universe is infinite or finite is one of the great open questions. It may be answered in our lifetimes, by better measurements of the cosmic microwave background, or by new ways of detecting the topology of space. Or it may remain open for centuries, passed down from one generation of astronomers to the next, a question bigger than any single lifetime. That is all right. That is more than all right. That is the nature of the enterprise. We are small creatures on a small planet, trying to measure the whole of existence. Patience is built into the work. Let me give you an image that might help as you lie there in the dark. Imagine an ant, again, that small creature we have used before. The ant lives on the surface of a vast balloon. The balloon is so large that the ant cannot see its curvature. The ant measures and finds the surface flat or very close to flat. The ant does not know if the balloon goes on forever, or if it curves around and closes on itself. The ant sends out signals, listens for echoes, looks for repeating patterns. The signals never return, the patterns never repeat. The ant knows that the balloon is either infinite or so large that its finitude is hidden. And the ant goes on with its life, building its small hills, raising its young, doing the work that ants do. The question does not torment the ant. The question is simply there, a companion, a quiet presence at the edge of its awareness. The ant does not need to solve the balloon. The ant just needs to live on it. We are like that ant. The question of infinity is with us, but it does not need to be resolved for us to rest. We can let it be large. We can let it be open. We can let the universe be whatever it is, infinite or finite, flat or curved, wrapped or unwrapped, without demanding an answer tonight. The answer will come, or it will not. The work will continue, with or without our attention. And right now, the only thing we need to do is breathe, and let the question float, and let the weight of the day slip away. There is one more way to think about infinity that sometimes helps. It is not about space, but about numbers. Imagine counting. You start with 1, then 2, then 3. You can keep going. You can always add one more. There is no largest number. The numbers go on forever. That is a kind of infinity we can hold in our minds without too much trouble. The infinity of space might be like that. It is not a number, but it shares the same quality of endlessness. There is always more. You can always go farther. There is no final galaxy, no last star, no ultimate particle. Just more, and more, and more. And if that thought makes you feel small, it is worth remembering that small is not the same as insignificant. A single note in a long song is still part of the song. A single moment in an infinite time is still real. You, lying there, are real. The universe, whatever its size, contains you, and that is enough. We have spent a while with this uncertainty now. We have turned it over, looked at it from different angles, let it settle. The next step on our journey is to ask an even deeper question. Not just whether the universe is infinite or finite, but whether the whole idea of outside makes sense at all. Because there is a strand of thought in physics that says the question we started with, what is outside the universe, might not be a question that has an answer. Not because the answer is hidden, but because the question itself runs into a wall of meaning. The framework of inside and outside, which we use so naturally for objects in space, might simply break down when applied to space and time as a whole. That is where we will go next. But for now, rest here. Rest in the not knowing. Rest in the open question. The universe is large, and we are small, and that is a peaceful thing to be. Now we step into a room that is a little different from the ones we have been in so far. The walls here are not made of space or time. They are made of language. They are made of the assumptions we carry into our questions without even noticing. We have been asking, all night, what is outside the universe? We have built up a careful picture of what the universe is, how far we can see, why there is no wall, what shape space might have. But now we have to ask a more unsettling question, or perhaps a more restful one, depending on how you look at it. We have to ask whether the question itself makes sense. We have to ask what outside even means when we are talking about the whole of space and time. This is not a trick. It is not a way of dodging the question or telling you that your curiosity is misplaced. It is a real position held by many thoughtful physicists, and it comes from taking seriously what we have learned about the nature of space and time over the last century. The idea is this: space and time are not just a background, a stage where things happen. They are physical things, woven together into a single fabric called space-time. And that fabric, according to our best understanding, began at a finite time in the past. The Big Bang was not an explosion in a pre-existing space. It was the beginning of space and time themselves. There was no before in any ordinary sense of the word. There was no empty stage waiting for the play to start. The stage itself came into being. The fabric itself began. If that is true, then the word outside may simply not apply. Outside is a spatial word. It points to a location in space. Something is outside the room. Something is outside the house. Something is outside the earth. In every case, we are pointing to a region of space that is separate from another region of space. The outside of a cup is the space beyond the cup's walls. The outside of a galaxy is the space between it and the next galaxy. Outside always means more space. So when we ask what is outside the universe, we are asking what space lies beyond all space. We are asking for a region of space that is not part of space. And that may be a contradiction. It may be like asking for a number larger than infinity, or a direction farther north than the North Pole. The metaphor of the North Pole is a classic one, and it is worth unfolding slowly, because it captures something deep. Imagine you are standing at the North Pole. Every direction you can point is south. There is no north. The concept of north, which is perfectly meaningful everywhere else on Earth, breaks down at the North Pole itself. If you ask, what is north of the North Pole, the question does not have an answer, not because the answer is hidden, but because the framework of north and south runs out. You have reached the limit of the coordinate system. You have reached the place where the concept stops working. Many physicists think the universe is like that. The word outside is a coordinate in the framework of space. At the boundaries of space and time, at the Big Bang, or at the edge of a finite universe, the framework may simply run out. The question may not have an answer, not because we are not clever enough to find it, but because the structure of reality does not supply one. This is a subtle and difficult idea. It is not the same as saying there is nothing outside the universe. Nothing is still a concept. A void is still a concept. Imagining an infinite dark emptiness beyond the edge of everything is still imagining a kind of space. The North Pole metaphor points to something more radical. It suggests that the very idea of beyond breaks down, that the question itself dissolves when you press on it, that the proper response to what is outside the universe might not be a description of a place, but a quiet recognition that the question has led us to the edge of what language and thought can do. This is philosophy, in a sense. It is the place where physics brushes up against the limits of human understanding. But it is philosophy that grows out of the physics, not philosophy that floats free of it. The physics tells us that space and time had a beginning. The physics tells us that space can be finite and unbounded. The physics tells us that the question, what happened before the Big Bang, may be as meaningless as what is north of the North Pole. These are not casual claims. They are hard-won insights from a century of grappling with general relativity and quantum mechanics and the expansion of the universe. And part of the honesty of cosmology is admitting when a question has carried us beyond the reach of the tools we have. So let us sit with that for a moment. The question that brought us here tonight, the question that seemed so simple at the start, may not be a question the universe answers. That does not make it a bad question. It makes it a deep question. It is a question that teaches us something about the nature of inquiry itself. Some questions close when you answer them. What time is it? 3 in the morning. The question is done. Other questions open outward. They lead to more questions. They lead, eventually, to the edge of the askable. And when you reach that edge, the proper response is not frustration. It is a kind of quiet wonder, the wonder of a child who has asked why enough times that the adult finally says, "I don't know. Nobody knows. Maybe the question doesn't have a why." That moment, the moment the chain of whys runs out, is not a failure. It is a meeting with the deep structure of things. And yet, and this is important, the scientific work does not stop there. The fact that outside may not be a meaningful concept for the universe as a whole does not mean we stop studying the universe's shape and size and structure. Those are still real questions with real, measurable answers. We can still ask whether the universe is flat or curved. We can still ask whether it is infinite or finite. We can still map the cosmic microwave background and chart the distribution of galaxies and test theories of the very early universe. The philosophical point about outside does not shut down the science. It simply clarifies what kind of questions the science can answer. The shape of space is a scientific question. The topology of the universe is a scientific question. The existence of other regions, other bubbles, other universes, if they can be inferred from data or theory, is a scientific question. But the word outside, applied to the whole of space and time, may be a word that points beyond what science can say, not because science is weak, but because the concept itself does not hold. Let me offer another image that might help. Think of a book. The characters in the book live in the world of the story. They move through the spaces the author has described. They have a past and a future within the narrative. If one of those characters asked, "What is outside the book?" the question would be hard to answer. The book is not an object inside its own world. The book is the world. The character cannot point to a place outside the pages, because outside the pages is not a place in the story. It is a different category entirely. Our universe may be like that. We may be asking a question that makes sense within the story, but points to something that is not part of the story at all. The author's desk, the reader's hands, these are real, but they are not locations you can reach by traveling through the narrative. They are not outside in the spatial sense. They are outside the framework entirely. This is not to say the universe is a book written by an author. It is only to say that categories can break, and when they do, the breaking is not a failure of the questioner. It is a sign that the question was reaching for something the framework was not built to hold. There is a quiet dignity in that. The question, "What is outside the universe?" is a question that has been asked by human beings for as long as we have been looking up at the sky and wondering. It is a question that has driven some of the deepest thinking in science and philosophy. If it turns out that the question reshapes itself rather than being answered directly, that is not a loss. That is the question doing its work. It is the question pushing us to see the shape of our own understanding, to notice where our concepts run out, to stand at the edge and look, not beyond, but inward, at the structure of thought itself. This may feel abstract. It may feel like we have drifted far from the warm, tangible universe of galaxies and starlight we were sitting with earlier. But the abstraction is part of the calm, if you let it be. There is something deeply restful about recognizing that some questions do not have answers, that the chain of why can end, not with a slam, but with a soft opening into quiet. That we are not required to solve the universe. We are only required to be here, inside it, wondering. The wondering itself is the point. The wondering is what we do, as humans, when we are at our most awake and our most humble. And the wondering does not need to produce an answer to be worthwhile. It only needs to be honest. So where does this leave us? It leaves us with two parallel tracks, both true, both worth walking. On one track, the scientific track, we keep measuring, keep testing, keep refining our picture of the universe's shape and size and origin. We look for the curvature of space. We search for the topology of the cosmos. We study the Big Bang and what came after. This work continues, and it is real, and it produces real knowledge. On the other track, the philosophical track, we recognize that some questions, including perhaps the one that started this whole journey, may not be questions the physical universe answers. They may be questions about the limits of language, or the limits of thought, or the limits of what it means to be a creature inside a system trying to think about the outside of the system. That recognition does not stop the science. It sits alongside it. It is a companion, not a rival. And for us, lying here in the dark, neither track demands anything from us right now. We do not need to choose between them. We do not need to solve them. We can simply let them be. The universe is vast, and its vastness includes this very moment, this very breath, this very drifting toward sleep. The question of what is outside is still there, still open, still beautiful in its openness. And we are still here, small and warm and safe, held inside the very thing we are wondering about. That is enough. That is more than enough. The path now leads us toward the very early universe, toward the first moments, toward a theory called cosmic inflation, which has become the leading explanation for how the universe got to be the way it is. It is a theory that will, in time, lead us to the idea of the multiverse, which is the closest thing science has to an answer to our original question. But we are not there yet. We are still here, in the quiet room of meaning and limits. Let the North Pole sit with you. Let the idea that some questions dissolve rather than resolve. Let it be restful, not frustrating. The universe does not owe us answers. It only owes us the chance to wonder. And we have that chance, right now, in the dark, as sleep draws near. We have been moving slowly through some of the largest ideas humans have ever tried to hold. We have talked about what the universe is, how far we can see, why there is no wall, what shape space might have, and whether the very idea of outside makes sense. Now we are going to step back in time, not just a few billion years, but all the way back to the very beginning, to the first tiny fraction of a second after everything began. This is the realm of the very early universe, a place where our ordinary understanding of space and time starts to stretch and bend. And it is here, in this earliest moment, that we find a theory that has become central to modern cosmology, a theory called cosmic inflation. The name sounds technical, but the core idea is simple. Cosmic inflation is the idea that in the very earliest moments of the universe, long before there were stars or galaxies or even atoms, space itself expanded at an enormous rate. Not the steady, gradual expansion we see today. Something much faster, something almost unimaginably rapid. In a tiny sliver of time, far less than a second, the universe grew from something smaller than an atom to something the size of a grapefruit, or perhaps much larger. That is the basic picture, a brief, intense burst of stretching right at the start. To understand why scientists came up with this idea, we have to think about a few puzzles the universe presents to us. Puzzles that the older, simpler model of the Big Bang had trouble explaining. The first puzzle is the one we have already touched on, the smoothness of the universe. When we look at the cosmic microwave background, the oldest light we can see, we find that it is almost perfectly the same temperature in every direction. The differences are tiny, about 1 part in 100,000. This is strange, because regions of the sky that are far apart from each other should never have been in contact. Light could not have traveled between them in the time since the Big Bang. There was no way for them to equalize their temperatures. So why are they so similar? It is as if two people on opposite sides of the world, who have never met and never spoken, showed up wearing the exact same outfit. It demands an explanation. The second puzzle is the flatness of the universe, which we discussed earlier. The universe appears to be very close to geometrically flat. But flatness, in the standard Big Bang model, is an unstable condition. It is like balancing a pencil on its point. A tiny deviation from perfect flatness early on would have grown over time, giving us a universe that was very obviously curved by now. The fact that we see near flatness today means the universe must have started out almost perfectly flat, to an extraordinary degree of precision. That seems like a very special, very unlikely starting condition. Scientists do not like very special, very unlikely starting conditions. They prefer explanations that flow naturally from physical processes. The third puzzle is called the monopole problem, and it is a bit more technical, but it is worth mentioning for completeness. Certain theories of particle physics predict that the early universe should have produced large numbers of heavy, stable magnetic particles called monopoles. We have never found any. The universe seems to be free of them. So where did they go? Cosmic inflation, first proposed by a physicist named Alan Guth in the late 1970s and early 1980s, offers a single idea that addresses all three of these puzzles at once. The idea is that the universe, in its very first moments, underwent a period of extremely rapid, exponential expansion. This expansion was driven by a special kind of energy field, sometimes called the inflaton field, that filled all of space. This field had a property that is hard to picture, but crucial to the theory. It acted like a kind of repulsive gravity. Instead of pulling things together, it pushed space apart, and it pushed with immense force, for a very brief time. During this inflationary period, which may have lasted for only a trillionth of a trillionth of a trillionth of a second, space stretched by a factor that is hard to write out in words. Some models suggest it grew by a factor of 10 to the power of 26, which is a 1 followed by 26 zeros. That is enough to take something smaller than a proton and blow it up to the size of a beach ball, or larger. After this burst, the inflation stopped, and the energy of the inflaton field was converted into the particles and radiation that would eventually form all the matter and light we see today. The standard Big Bang evolution then took over, with the universe continuing to expand, but at a much slower rate. This simple idea solves the three puzzles neatly. The smoothness puzzle is solved because, before inflation, all the regions we now see far apart in the sky were once in very close contact. They were neighbors in the tiny pre-inflation universe. They had plenty of time to equalize their temperatures. Then inflation stretched them apart, flinging them to opposite sides of the sky. But they carried with them the memory of their shared past. They look the same because they were once together. The flatness puzzle is solved because inflation takes any initial curvature and stretches it out, just as blowing up a balloon makes its surface look flatter and flatter the larger it gets. If the balloon is blown up to enormous size, the part we can see, the tiny patch we observe, will look flat to us. And the monopole puzzle is solved because inflation dilutes any leftover particles. If monopoles were produced before inflation, they would have been spread so thin by the stretching that we would be very unlikely to find one in our observable patch. All of this is mainstream cosmology. Inflation is not a fringe idea. It is the leading framework for understanding the earliest universe, and it has been supported by a great deal of evidence over the past several decades. The patterns we see in the cosmic microwave background, the tiny temperature differences that are the seeds of all structure in the universe, match the predictions of inflation with remarkable precision. The theory has been refined and tested and compared to data, and it has held up well. That does not mean it is proven, in the way that gravity or evolution are proven. The details of inflation are still being worked out. Exactly what the inflaton field was, exactly how it started, exactly how it ended, these are open questions. But the broad picture, a very early period of very fast expansion, is well supported and widely accepted. And now we come to the part that connects back to our original question. What does inflation have to do with what is outside the universe? The connection comes from a particular implication of the theory, an implication that was noticed soon after inflation was first proposed. If inflation happened once, in one region, it raises the question, did it happen only once, everywhere, and then stop cleanly, or might it have stopped in some places while continuing in others? In many models of inflation, the answer is that it stops locally, but continues globally. The inflaton field decays into ordinary particles in some regions, creating bubbles of normal space like the one we live in. But between those bubbles, inflation keeps going, stretching space faster than the bubbles can grow. And because inflation is so powerful, the space between the bubbles grows faster than new bubbles can form. The result is an eternal, self-replicating process. Inflation never ends everywhere at once. It always continues somewhere, creating new bubbles, new regions, new pocket universes, forever. This is the idea that leads, naturally and almost inevitably, to the multiverse. If inflation is eternal, if it keeps spawning bubble universes without end, then our universe is just one among many. One bubble in a vast, inflating sea. One pocket of calm in an endless stretch of rapidly expanding space. And that sea, that larger space, could be the closest thing to an outside that our universe has. It is not outside in the sense of being a different kind of thing. It is more space. It is the same fabric, the same physical reality. But it is forever beyond our reach, separated from us by the furious stretching of inflation itself. We will explore the multiverse idea more fully in the next section, and we will be careful to label it for what it is, a hypothesis, not a confirmed fact. But for now, the important thing is to understand inflation itself. It is the bridge between the universe we can see and the larger reality that may lie beyond. It is the theory that makes the multiverse plausible, that gives it a mathematical foundation, that turns it from a philosophical daydream into a scientific proposal that can be discussed and debated and, perhaps one day, tested. Inflation also gives us a new way to think about the size of the whole universe. If inflation happened, the whole universe is vastly larger than the observable part. The observable universe is 93 billion light-years across. The whole universe, in the simplest inflation models, is at least many orders of magnitude larger. Some estimates put it at a size that is to the observable universe as the observable universe is to a single atom. And that is a conservative estimate. In eternal inflation, the whole universe may be truly infinite, an endless sea of inflating space, dotted with bubble universes like ours. We cannot see the other bubbles, we cannot interact with them, but they are out there, if the theory is correct, separated from us by distances so vast that light from them will never ever reach us. This is the point where the science starts to brush up against the limits of what we can observe. Inflation makes predictions that we have tested and continue to test, in the cosmic microwave background and in the distribution of galaxies. But the idea of eternal inflation and the multiverse it implies takes us beyond the observable. It takes us into a realm where the usual rules of science, make a prediction, test it with an experiment, become very difficult to apply. Some physicists are comfortable with this. They argue that if a theory is well supported in the observable part, we should trust its implications for the unobservable part as well. Other physicists are uneasy with it. They argue that if an idea cannot be tested, it is not really science in the traditional sense. This debate is ongoing. It is one of the live conversations in cosmology today. For our purposes, lying here in the dark, we do not need to settle that debate. We can simply appreciate inflation for what it is, a beautiful, powerful idea that explains a great deal about the universe we see, and that opens the door to speculations about what we cannot see. It is a theory born of honest puzzles, built with careful mathematics and tested against the oldest light in the sky. It has changed the way we think about the early universe, and it has made the question of what is outside the universe a little more concrete, a little more scientifically tractable. Whether it is true in its strongest form, whether we live in a multiverse of countless bubbles, is a question that remains open. But the framework is there. The bridge is built. We can walk across it, slowly, carefully, and see where it leads. So let inflation settle in your mind, if it will. A brief, furious stretching at the dawn of time, an expansion driven by a strange kind of energy that pushed space apart. A theory that explains why the sky looks the way it does, and that hints at a reality far larger than the one we can see. It is a theory that contains a certain kind of poetry, a certain kind of calm. The universe, in this picture, is not a static thing. It is a process. It is an ongoing event. It is a stretching, bubbling, inflating sea of becoming, and we are small parts of one small region, drifting on the currents of space and time. The next step is to look more directly at the multiverse idea itself, to name it clearly as a hypothesis, not a fact, to describe what it would mean if it were true, and what it would mean if it were not. That is where we will go. But for now, rest in the early universe. Rest in the first fraction of a second, when everything was small and hot and stretching fast. The universe has been expanding ever since, and we are part of that expansion, carried along by the same fabric that began stretching all those billions of years ago. That is a thought you can hold or let go. The stretching continues, the drifting continues, and sleep, when it comes, is just another gentle motion in the long, slow expansion of the night. And so we come to the idea that has been waiting for us all night. The idea that sits at the edge of what we have been discussing, like a shape half seen in the distance. The multiverse. It is a word that carries a lot of weight, a word that has appeared in countless stories and films and late-night conversations. But what does it actually mean in the context of real science? And what is its status? Is it a proven fact, a likely truth, a tentative guess, or something else entirely? Tonight, we are going to sit with that question honestly and carefully, without reaching for drama or certainty. We are going to look at the multiverse idea for what it is, a family of hypotheses, not a confirmed finding. Let me say that again because it is the most important sentence in this section. The multiverse is a hypothesis. It is not a fact. It has not been observed. It has not been tested directly. It may never be testable, and some physicists question whether it is even science in the traditional sense. This does not mean it is wrong. It does not mean it is worthless. It means it is an idea, a serious idea, built on real mathematics and connected to real theories, but an idea that has not yet crossed the line into established knowledge. And that is fine. Science is full of such ideas. They are the seeds from which future understanding grows. Or they are the beautiful structures that turn out to be wrong, and in being wrong, teach us something new. So let us begin by being clear about what the multiverse idea actually says. The word itself, multiverse, simply means many universes. But different branches of physics mean different things by that. There is not one multiverse hypothesis. There are several, and they come from different starting points, different equations, different puzzles that scientists are trying to solve. They share a common theme, that what we call the universe may be only a small part of a much larger reality, but they differ in what that larger reality is like and how the parts relate to each other. The version we have already brushed up against is the inflationary multiverse. This is the one that grows most directly out of the theory of cosmic inflation we discussed earlier. In this picture, the rapid stretching of space that happened in the very early universe did not stop everywhere at once. It stopped in some places, creating bubbles of calm, normal space like the one we live in. But between those bubbles, inflation continued, stretching space faster and faster, forever. New bubbles form, new pockets of normal space nucleate out of the inflating background, each one a separate universe with its own local conditions. Our universe, in this picture, is just one bubble among countless others, floating in an endless, ever-expanding sea. The key word here is endless. In many models of eternal inflation, the process never stops. It has no final state. It just keeps going, producing more and more bubble universes without limit. If this picture is correct, then the multiverse is truly infinite. There are infinitely many bubble universes, each one a separate region of space, each one perhaps with its own laws of physics, its own constants, its own distribution of matter and energy. Most of these bubbles would be forever beyond our reach. The space between them is expanding so fast that light from one bubble can never catch up with another. They are causally disconnected, which is the technical way of saying they cannot talk to each other, they cannot send signals, they cannot interact. They are islands in a sea of stretching space, each one alone. This is a strange and haunting picture, if you sit with it, but it is not the only multiverse picture. Another comes from a different area of physics entirely, from a set of ideas called string theory. String theory is an attempt to describe all the fundamental particles and forces of nature as tiny vibrating strings. It is a mathematically rich framework, but it comes with a complication. For the theory to be consistent, it seems to require that the universe has more than the 3 dimensions of space we experience. 6 or 7 extra dimensions, curled up so small we cannot see them. The way those extra dimensions are curled up, their shape, their size, their topology, determines the properties of the universe we see. The masses of particles, the strengths of forces, the very laws of physics, all depend on the geometry of those hidden dimensions. Here is where the multiverse comes in. It turns out that there is an enormous number of possible ways to curl up those extra dimensions. Enormous. Numbers like 10 to the power of 500, which is a 1 followed by 500 zeros. Each possible configuration gives a different set of physical laws, and string theory, by itself, does not pick one. It offers a vast landscape of possibilities, and our universe, with its particular laws and constants, is just one point on that landscape. This is called the string theory landscape, and it is another version of the multiverse. Not bubbles in an inflating sea, but different regions of a vast landscape of possible realities, each one perhaps physically realized somewhere in a larger space. There are other multiverse ideas as well. Some come from the many worlds interpretation of quantum mechanics, which suggests that every quantum event spawns a new branch of reality, a new parallel world. Some come from more abstract mathematical considerations, ideas about the nature of reality and the foundations of physics. But the inflationary multiverse and the string theory landscape are the 2 that get the most attention in cosmology. They are the 2 that connect most directly to questions about what is outside our universe. And here is the thing. None of these ideas have been confirmed by observation. We have never seen another bubble universe. We have never detected a signal from another branch of the quantum wave function. We have never found evidence of another point on the string theory landscape. The multiverse, in all its forms, remains a hypothesis. A very interesting hypothesis. A hypothesis that many smart and careful scientists take seriously, but a hypothesis nonetheless. This is where the conversation gets delicate. Some physicists argue that the multiverse is not just unobserved, but unobservable in principle. If other bubble universes are forever causally disconnected from us, if no signal can ever travel between them and us, then we can never, even with perfect instruments and unlimited time, gather any data about them. And if an idea cannot be tested, even in principle, is it science or is it something else? A philosophy? A metaphysics? A mathematical daydream? There is a real, ongoing debate about this within the physics community. It is not a settled question. It is a live tension. Other physicists push back. They argue that the multiverse is a prediction of theories, inflation and string theory, that are well supported in other ways. If we trust those theories where we can test them, they say, we should trust them where we cannot. Moreover, they argue, there may be indirect ways to test the multiverse. Perhaps we can find evidence of collisions between our bubble and another bubble in the distant past, written into the cosmic microwave background. Perhaps we can measure the shape of the universe precisely enough to determine whether we live in a bubble at all. Perhaps there are statistical properties of our universe that only make sense if we are one of many. These are active areas of research, and the book is not closed. But for tonight, for our purposes, the honest position is simply this. The multiverse is an idea, a beautiful, vast, mind-stretching idea. An idea that arises naturally from some of our best theories of the early universe and the fundamental nature of reality. An idea that, if true, would mean that our entire observable universe, all 93 billion light-years of it, with its 2 trillion galaxies and its countless stars, is just one small bubble in an endless foam of universes. It would mean that the question, what is outside the universe, has an answer, and the answer is more universes, or more space, or more of the same inflating fabric. It would mean that reality is larger, stranger, and more prolific than we ever imagined. But it might not be true. It might be wrong. The multiverse might be a mathematical artifact, a quirk of our equations that does not correspond to anything real. The debates about its testability might never be resolved, the evidence might never come, and that is all right. Science does not require us to have an answer to every question. It only requires us to be honest about what we know, what we do not know, and what we are guessing. The multiverse is a guess, a very sophisticated guess, built on a great deal of careful work, but a guess all the same. There is something restful about this, I think. The multiverse does not need to be true to be worth thinking about. It is a way of exploring the limits of our theories, a way of pushing our ideas to their logical conclusions and seeing where they lead. Even if it turns out to be wrong, it has already served a purpose. It has stretched our imaginations. It has forced us to confront deep questions about what science is and what it can do. It has reminded us that the universe, whatever its true nature, is vast and strange and not yet fully understood. And for you, lying there in the dark, the multiverse can be whatever you need it to be. It can be a fascinating idea to turn over in your mind. It can be a comforting thought that our universe is not alone, that there are other realities out there, other places, other possibilities. Or it can be a thought you let go of entirely because it is too large, too uncertain, too distant from the warm reality of your bed and your breath and the quiet of the night. There is no wrong way to hold it. It is an idea, not a demand. It does not require your belief. It only asks for your honest attention, for as long as you care to give it. So let the multiverse sit with you, if it will. A hypothesis, not a fact. A guess, not a finding. A beautiful, open question in a field full of open questions. We will go next into what would separate these universes, if they exist. What the space between the bubbles might be like. What the walls, if there are walls, might be made of. But for now, just let the idea float. Many universes, or just one. The data has not told us yet, and that is fine. That is the quiet, honest place we have been in all night. The place of not knowing. The place of patient, careful wonder. The place where sleep comes easiest, because there is nothing to solve, nothing to prove, nothing to hold on to. Just the vast, open dark, and the sound of a voice, and the slow drift toward rest. We have let the multiverse idea float for a while now, hanging in the dark like a distant, unconfirmed thought. And if you are still awake, still drifting with the words, you might be wondering something quite natural. If there are other universes out there, other bubbles, other regions of space disconnected from our own, what separates them? What lies between us and them? Is there a wall, a void, a nothing? Or is it something else, something more familiar, something we have already talked about tonight? These are gentle questions. They are the kind of questions the mind asks when it is trying to build a picture, trying to furnish the empty spaces of an idea with something it can see. And the answers, as with so much else on this journey, are a mixture of careful scientific imagining and honest uncertainty. We do not know what separates the universes, if they exist. We cannot know, not yet, not with any instrument we have. But the theories that give rise to the multiverse also give us some hints, some soft-edged images, about what the gaps between the bubbles might be like. Let us start with the inflationary multiverse, the one we have spent the most time with. In this picture, our universe is a bubble, a region where inflation stopped and the energy of the inflaton field decayed into ordinary particles and radiation. That is the space we live in. It is vast, but it is finite, or at least it is a finite patch within a larger inflating whole. Outside our bubble, beyond the region where inflation ended, there is more space. Not a different kind of existence, not a void of pure nothing, just more space. space that is still inflating, space that is still stretching at that enormous exponential rate, space that is still filled with the inflaton field, the same strange energy that drove the expansion in the first moments. So the first image to hold is not a wall, and not a void, but a continuation. The space outside our bubble is still space. It obeys the same laws of physics, as far as we can tell. It has the same properties. It is simply in a different state. It is like a vast ocean of water, and our bubble is a region where the water has frozen into ice. The ice is still water. It is just in a different phase. The boundary between the bubble and the inflating outside is a phase boundary, a place where the state of space changes from inflating to non-inflating. It is not a hard wall. It is more like the surface of a lake, where water meets air. A transition, a change in conditions. And what about other bubbles, other universes? They would be out there too, scattered through the inflating sea like bubbles in a glass of something fizzy. Each one is a region where inflation ended. Each one is a pocket of calm, expanding more slowly than the space around it. But here is the crucial point. The space between the bubbles is expanding so fast that the bubbles can never catch up with each other. The distance between them grows faster than light can travel. So even though they exist in the same larger space, they are forever isolated. They cannot interact. They cannot send signals. They cannot collide, except perhaps in very rare and very early circumstances. They are separate worlds, not because they are in different dimensions, but because the stretching of space has pulled them beyond each other's horizons. This is a soft, spacious image. It is not claustrophobic. It does not press in on you. The multiverse, in this picture, is not a crowded place. It is a vast, open sea of stretching space, dotted here and there with bubbles of calm. Most of it is empty, or rather filled only with the inflaton field, which is not a thing you could see or touch. It is a field, like a magnetic field, a condition of space itself. The bubbles are few and far between, separated by distances that are, for all practical purposes, infinite. Our bubble is alone. We are alone, not in a sad way, but in a spacious, quiet way. The nearest other bubble might be farther from us than the entire observable universe. We will never see it. It will never see us. We are neighbors only in the most abstract sense, sharing the same larger space but never meeting. Now, some models of inflation allow for the possibility of bubble collisions. If two bubbles formed close enough together, in the very early moments, their walls might have touched before the stretching of space pulled them apart. Such a collision would leave a mark. It might show up as a circular pattern in the cosmic microwave background, a ring of slightly different temperature. Scientists have looked for such rings. So far, they have not found any clear evidence of them. The data is consistent with no collisions. But the search continues. It is one of the few ways we might, if we are very lucky, get a glimpse of something beyond our bubble. A bruise on the sky, left by a neighbor we can never visit. So the space between universes, if the inflationary multiverse is real, is more space. It is not a void of nothingness. It is not a metaphysical gap. It is just more of the same fabric, stretched thin and expanding fast. This is an important point, and it circles back to something we talked about earlier. The question, what is outside the universe, keeps running into the same wall. Outside is a spatial word. It points to a location in space. If the space beyond our bubble is still space, then it is not really outside in the way we might have meant. It is just more of the same. The multiverse is not a collection of universes floating in a nothing. It is a single, continuous fabric of space, some parts of which are inflating and some parts of which have stopped. Our bubble is a region, not a separate object. The whole thing is the universe, in the largest sense. We just happen to live in one of its calmer neighborhoods. Let me offer an image that might help. Imagine a vast, dark ocean, stretching out in all directions without end. The ocean is the inflating space. Now imagine that, here and there, patches of the ocean have frozen into ice. Each frozen patch is a bubble universe, a region where inflation ended and normal space began. The ice is still water. It is made of the same substance as the ocean, but it is solid, calm, no longer churning. Our universe is one of those frozen patches. We live inside the ice. We can see other parts of the ice, but we cannot see the ocean beyond, because the ocean is expanding so fast that light from it cannot reach us. And we cannot see the other patches of ice, for the same reason. They are out there, but they are beyond our horizon, lost in the vast, dark, stretching sea. This image is not perfect. No image ever is when you are trying to picture the whole of reality. But it captures something important. The boundaries between universes, if they exist, are not hard walls. They are horizons. They are limits of what we can see and interact with, not limits of what is. And the space between them is not a void. It is a dynamic, energetic, expanding something. It is space in a different phase, but still space. What about other kinds of multiverses? The string theory landscape, for instance. In that picture, the different universes are not bubbles in an inflating sea. They are different regions of a much larger space, each with its own local laws of physics, determined by the shape of the extra dimensions. The boundaries between these regions, if there are boundaries, would be domain walls. A domain wall is a real physical thing, a kind of membrane where the properties of space change from one set to another. Crossing a domain wall would be like crossing a border into a country where the laws of nature are slightly different. The electron might have a different mass. The strength of gravity might be different. The whole structure of particle physics might change. But the wall itself is still a physical thing, embedded in a larger space. It is not an edge of existence. It is a transition within existence. In the many worlds interpretation of quantum mechanics, the separation is different again. The different branches of the wave function are not separated by space at all. They are separated by what physicists call decoherence, the process by which quantum possibilities become distinct and non-interacting. In this picture, there is no spatial gap between the worlds. They exist in the same space, but they cannot communicate. They are parallel, not adjacent. The separation is mathematical, not physical. This is a harder idea to picture, and it is the one most distant from the inflationary bubble model. But it shares the same feature. The worlds are separated by something. A phase boundary, a domain wall, a quantum decoherence, something that makes interaction impossible. All of these images bring us back to the same quiet place. If there are other universes, we cannot reach them. Not with rockets, not with telescopes, not with any technology we can imagine. The gaps between us and them are not gaps of distance that could be crossed with enough time and speed. They are gaps of principle. The laws of physics themselves, as we currently understand them, forbid contact. The other universes, if they exist, are forever beyond our grasp. We can speculate about them. We can build mathematical models of them. We can search for indirect signs, like bruises on the sky. But we cannot visit them. We cannot talk to them. We are, in a very real sense, cosmically alone. This might sound sad, but it does not have to be. There is a kind of peace in it. The multiverse, if it is real, is not a place we are excluded from. It is not a party we were not invited to. It is simply the larger structure of reality, and we are part of it, in our own small way. We are a bubble among bubbles, a frozen patch in the infinite sea. And that is enough. That is our place. We do not need to visit the other bubbles. We do not need to cross the domain walls. We have our own universe to explore, our own 93 billion light-years of space, our own 2 trillion galaxies. That is more than we could ever see in 100 lifetimes. It is more than enough. So let the images settle, if they will. Bubbles in an ocean, ice on water, domain walls in a larger space. These are not facts, they are hypotheses. They are the pictures that fall out of the mathematics when we push our theories to their limits. They may be right, they may be wrong, but they are spacious pictures. They are pictures that give the mind room to wander. They do not press in with hard edges and solid walls. They open outward, into more space, more possibility, more of the same endless fabric we have been drifting through all night. And notice, as we near the end of this section, how the question has shifted. We began by asking what is outside the universe. We imagined a wall, an edge, a boundary. Then we learned there is no wall. Then we considered the multiverse and found that the outside might be more space, inflating space, dotted with other bubbles. And now we see that the very word outside is still giving us trouble. If the other bubbles are separated from us by more space, then they are not really outside in the way we originally meant. They are just far away, unreachably, impossibly far away, but still within the same larger reality. The question has bent back on itself, as the best questions do. It has taught us something about the limits of our words, the limits of our images, the limits of our ability to think about the whole of things. That is where we will leave this for now. The space between universes, if there is such a thing, is probably more space. Not nothing, not a wall, just more of the same, in a different state. And we are here, in our small bubble, drifting. The inflating sea is out there, stretching forever, and we will never see it. But we can imagine it. We can hold it in our minds, like a vast, dark, quiet ocean, and then let it go. The next step on our journey is to gather all these threads together, all these open questions and honest uncertainties, and see if we can find a way to live comfortably inside them, to rest in the not knowing, to let the vastness be a comfort, not a weight. That is where we will go next, as the night deepens and sleep draws closer. We have traveled a long way together tonight. We have moved from the simple, childlike question of what lies outside the universe, through the careful definitions of what the universe even is, through the measurable vastness of the observable bubble, through the dissolving of walls and the mapping of shapes, through the honest admission that we do not know if the universe is infinite or finite, through the philosophical quiet of the North Pole, through the furious stretching of inflation, and into the speculative, spacious realm of the multiverse. We have covered a great deal of ground, and now, as the night deepens and sleep begins to pull at the edges of your awareness, it is time to gather these threads together, not to tie them up neatly, not to solve them, but to see if we can find a way to live comfortably inside them, to rest in the not knowing, to let the vastness be a comfort, not a weight. This is the section where we slow down, where the sentences begin to shorten, where the pauses grow longer, where the words become more like a lullaby and less like a lesson. Because the point of this whole journey was never to arrive at a final answer. The point was to wander through the questions, to feel their shape, to let them be large and open and unresolved. And now, as we prepare to close, we are going to reflect on what it means to live with open questions, what it means to be comfortable with not knowing, what it means to be a small, warm, curious creature inside a universe that has not yet revealed all its secrets. Many of the universe's biggest questions remain open. This is a simple fact. It is not a shortcoming of science. It is not a failure of our instruments or our minds. It is simply where we are in the long, slow, generational project of understanding the cosmos. We have learned an enormous amount in the last few centuries. We have mapped the planets and the stars and the galaxies. We have measured the age of the universe and the speed of light and the expansion of space. We have detected gravitational waves and imaged black holes and sent probes to the edges of our solar system. But the deepest questions, the ones about the origin and the shape and the fate of the whole thing, remain open. And that is normal. That is how science works. It is a process, not a product. It is a journey, not a destination. Careful measurement, patience, and honest uncertainty are what real science is built from. These are not weaknesses, they are strengths. The scientist who says, "I don't know yet," is doing something brave. They are holding the door open for more evidence, more thinking, more refinement. They are refusing to fill the gap with a comforting story. They are waiting, sometimes for decades, sometimes for a whole career, for the data to come in. And sometimes the data never comes. Sometimes the question outlasts the questioner, and that is all right. The question gets passed on, like a baton in a relay race, to the next generation of curious minds. The work continues. The patience continues. The not knowing continues. Imagine, if you will, an astronomer from 100 years ago. They are standing at a telescope on a cold mountain, looking up at the night sky. They know that the Milky Way is a vast collection of stars, but they do not yet know if the Milky Way is the whole universe, or if those faint, fuzzy patches they call nebulae are other galaxies, other Milky Ways, far beyond our own. The question is open, it is debated. Some think the nebulae are nearby clouds of gas, others think they are distant island universes. The astronomer at the telescope does not know the answer. They may not live to see the answer, but they keep observing, they keep taking plates, they keep measuring. And eventually, because of their patient work, and the work of others like them, the answer comes. Edwin Hubble, using the largest telescope of his time, measures the distance to the Andromeda Nebula and finds that it is far beyond the Milky Way. The universe suddenly grows. The question is settled. A new question opens. This is the rhythm of cosmology. Questions open, questions close, new questions open in their place. The astronomer of 100 years ago did not know about the cosmic microwave background. They did not know about dark matter or dark energy. They did not know about inflation or the multiverse. Each generation inherits the open questions of the previous one, answers some of them, and leaves new ones for the next. This is not a sign of failure. It is a sign of health. A field with no open questions is a dead field. Cosmology is vibrantly, wonderfully alive with questions, and we get to live inside that aliveness. We get to be part of the asking, even if we are not the ones who will find the answers. There is a quiet dignity in this, a peace that comes from recognizing that we are part of something larger than ourselves. The questions we have been sitting with tonight: is the universe infinite? Is there a multiverse? What is outside everything? These are questions that will probably outlast us. They may outlast our children and our children's children. They are questions on the scale of centuries and millennia, not years. And that is not a source of frustration, it is a source of perspective. It puts our own small lives into a larger frame. It reminds us that we are not the center of the story. We are characters in a much longer narrative, a narrative that began long before we were born and will continue long after we are gone. And our part, our small but real part, is to wonder, to ask, to pass the questions on. So let us gently return to the ideas we have covered tonight, not to fix them in memory, but to let them drift through the mind one last time before we let them go. We began with the observable universe, the bubble of light we can actually see, 93 billion light-years across, 2 trillion galaxies, a vast sphere of visibility, bounded not by a wall but by a horizon, a limit of time and light. Beyond that horizon, we have every reason to think there is more galaxies, more stars, more space. The universe does not end where our vision ends. It continues on and on into regions we can never see. We then asked why there is no wall. We looked at the human instinct to imagine the universe as a giant room, and we let that instinct soften. We remembered the ancient sailors who feared falling off the edge of a flat earth, and how the earth turned out to be curved and continuous, with no edge at all. The universe may be like that. It may be curved, finite but unbounded, or it may be flat and infinite, stretching away without end. In neither case is there a wall. In neither case is there a place where space just stops. We then looked at the shape of space itself, flat, like an endless sheet, curved like a sphere, curved like a saddle. The measurements from the cosmic microwave background and other sources tell us the universe is very close to flat, so close that we cannot detect any curvature with our current instruments. A flat universe can be infinite, or it can be finite and wrapped around itself, like a cosmic loop. We do not know which. The question is open. We sat with the honest uncertainty of that. Scientists do not know if the universe is infinite or finite. It is one of the great open questions, and it may remain open for a very long time. We are like the ant on the vast balloon, measuring and measuring, finding flatness, unable to tell if the balloon goes on forever or closes back on itself. And that is all right. We don't know yet is a real, respected answer. We then pressed on the question itself. What does outside even mean when we are talking about the whole of space and time? We considered the North Pole and how the concept of north breaks down when you reach it. We considered the possibility that space and time began together, and that outside may not point to a place at all. The question may dissolve rather than resolve, and that dissolution is not a failure. It is a sign that we have reached the edge of our framework, the place where our words run out. We then stepped back to the very early universe, to the theory of cosmic inflation. A brief, furious stretching, right at the beginning. A theory that explains why the universe is so smooth and so flat and so uniform. A theory that is well supported by evidence, though its details are still being worked out. And a theory that opens the door to the multiverse. If inflation never fully stops, it can keep spawning bubble universes forever. Our universe would be just one bubble among countless others, floating in an endless, inflating sea. We looked at the multiverse idea honestly, naming it as a hypothesis, not a fact. It is a beautiful, mind-stretching idea, but it has not been tested. It may not be testable. Some physicists embrace it, others are skeptical. The debate is ongoing, and we, lying here in the dark, do not need to pick a side. We can simply appreciate the idea for what it is, a possibility, a guess, a way of thinking about the larger structure of reality. We then asked what would separate the universes, if they exist, and the answer, as best we can tell, is more space. Not nothing, not a void, just more of the same fabric, stretching fast. The bubbles are islands in an inflating ocean, forever separated by horizons they cannot cross. The multiverse, if it is real, is a vast, quiet, spacious place, and we are in one small corner of it, drifting. All of these ideas are still with us, even if we let go of them. They have been part of the journey. They are the landscape we have wandered through, and now, as we near the end, we can see the shape of the whole walk. What we can see, why there is no wall, the honest unknowns beyond. The universe is large, and we are small, and that is a peaceful thing to be. So how do we live comfortably with not knowing? The answer, I think, is to recognize that not knowing is the natural state of a finite mind in an infinite, or at least very large, reality. We are not supposed to have all the answers. We are not built for that. We are built to wonder. We are built to ask. We are built to sit in the dark with the people we love and talk about the big questions, not because we expect to solve them, but because the talking itself is good. The wondering itself is good. It is one of the things that makes us human. It is one of the things that makes the night feel full instead of empty. The astronomers over generations, the ones who passed the questions down, they knew this. They knew that they would not live to see all the answers. They worked anyway. They measured anyway. They wondered anyway. And they passed the wonder on. That is what we are doing tonight in our small way, passing the wonder on, letting the questions breathe, letting the not knowing be a space we can rest in, rather than a gap we must fill. So let your breathing slow. Let the weight of the day finish its fading. The universe is out there, vast and dark and full of stars and galaxies, and perhaps other bubbles, and perhaps infinite space, and perhaps closed loops. And you are here, warm and safe, held inside the very thing you were wondering about. There is nothing to solve tonight, nothing to prove, nothing to hold on to, just the quiet, just the dark, just the slow, gentle drift towards sleep. The questions will still be there in the morning, if you want them. And if you do not, that is fine too. They do not need your attention. They have been waiting for billions of years. They can wait a little longer. Quiet, drift off close. The questions can wait. They have been waiting for a very long time, and they will still be there when the morning comes, if you choose to pick them up again. But right now, in this moment, there is nothing you need to do, nothing you need to figure out, nothing you need to hold in your mind. the journey we have taken tonight is complete. The path has brought us here, to the quiet edge of sleep, and here we can rest. We began with a simple question, a child's question, asked in the dark. What is outside the universe? We did not answer it, not in the way we answer a question about the time or the weather. Instead, we let the question open. We let it lead us through rooms of thought, one after another, each one a little larger and a little quieter than the one before. We looked at what we can see, the great bubble of light we call the observable universe, 93 billion light-years across. We learned that this bubble is not the whole thing, it is just our patch, our view, our small window onto the whole. We learned that there is no wall, no edge, no boundary where space stops and something else begins. The universe, as far as we can measure, is smooth and continuous, without seam or border. The horizon we see is a horizon of time and light, not a wall of brick or stone. Beyond it there is more space, more galaxies, more of the same stretching fabric we are woven into. We thought about the shape of that fabric, flat like an endless sheet, curved like the surface of a ball. The measurements point toward flatness or something very close to it. A flat universe can be infinite, going on forever in all directions, without limit, without end. Or it can be finite, wrapped around itself in ways we cannot see. We do not know which. That question is still open. It is one of the great open questions. We sat with that not knowing. We let it be what it is, an honest admission, not a failure. Scientists do not know if the universe is infinite or finite. They may not know for a long time, and that is all right. That is the nature of the enterprise. We are small creatures on a small planet, trying to measure the whole of existence. Patience is built into the work. We asked what outside even means, and we found that the word might break down when applied to the whole of space and time, like asking what is north of the North Pole. The question might dissolve rather than resolve. It might point to a limit of language, a place where our concepts run out. And that dissolution is not a disappointment. It is a kind of release. It means we do not have to find an answer. The question itself has done its work. It has stretched our minds. It has shown us something about the shape of our own understanding. We traveled back to the very early universe, to the first fraction of a second, when space itself stretched at an enormous rate. We learned about cosmic inflation, the theory that explains why the universe is so smooth and so flat and so uniform. And we followed that theory to its natural edge, to the idea of the multiverse, a vast, inflating sea, dotted with bubble universes like ours. A hypothesis, not a fact. A beautiful, open possibility, not a settled truth. We imagined what might separate those bubbles, if they exist. More space, not nothing, not a void, just more of the same fabric, stretching fast. The multiverse, if it is real, is a spacious, quiet place. And we are in one small corner of it, drifting. We sat with the uncertainty of all of it. We recognized that not knowing is the natural state of a finite mind in an infinite, or at least very large, reality. We are not supposed to have all the answers. We are not built for that. We are built to wonder. We are built to ask. We are built to sit in the dark and let the big questions float, not because we expect to solve them, but because the wondering itself is good. It is part of being human. It is part of being alive. And now, here we are, at the end of the path. The words have been spoken. The ideas have been turned over and held up to the faint light of attention. There is nothing new to add, no final fact, no closing insight, just the quiet, just the dark, just the slow, steady rhythm of your breath. You are small, that is true. You are a tiny point of warmth and awareness in a universe so large it defeats easy description. But small does not mean insignificant. The universe, whatever its true size, contains you. You are part of it. You are made of the same stuff as the stars and the galaxies and the space between them, the same atoms, the same fundamental particles, the same brief, bright moment of existence. You belong here. You belong to the fabric, just as the fabric belongs to you. The questions we have asked tonight are your questions. They are the inheritance of every curious mind that has ever looked up at the night sky and wondered, what is out there? How far does it go? Is there an edge? What lies beyond? These questions have been asked by humans for thousands of years, around campfires and in observatories, by children lying in the grass, and by physicists at blackboards. You are part of that lineage. Your wondering connects you to everyone else who has ever wondered. You are not alone in the not knowing. You are in very good company. So let the questions go, for now. Let them drift away, like leaves on a slow stream. They will still be there in the morning, or the next night, or the night after that. You can pick them up again whenever you like. They are patient. They have waited for billions of years. They can wait a little longer. Feel the weight of your body on the bed. Feel the softness of the pillow. Feel the warmth of the blanket. You are here. You are safe. The universe is out there, doing what it does, expanding and stretching and burning and cooling, and it does not need your attention. It does not need your understanding. It just is, and you just are. Two facts, sitting side by side, asking nothing of each other. The night is deep now. The world outside your window is quiet. The stars, if you could see them, are turning slowly in their ancient patterns. The earth is rotating under you, carrying you toward the dawn, but the dawn is still hours away. There is time. There is so much time. There is nothing but time and the dark and the sound of a voice that is about to fall silent. So this is where we leave it, not with a bang, not with a revelation, not with a call to action or a summary to remember, just with stillness, just with quiet, just with the sense that it is all right not to know everything. It is all right to be small. It is all right to let the big questions stay big, and to let yourself rest instead of solving them. The universe will still be there when you wake, and so will the questions if you want them, and so will the quiet if you do not. Sleep is the destination, it always was. Everything else was just the path. And the path has brought you here, to this moment, to the edge of waking, to the soft, dark border where thoughts dissolve and dreams begin. Cross over, when you are ready. Let go of the words. Let go of the ideas. Let go of the whole long, gentle journey we have taken together. It has been a pleasure to walk with you. It has been an honor to share the dark. Sleep well. The universe holds you, and you hold the universe, in your own small way, by wondering about it. That is enough. That is more than enough. Good night.